and welcome back to another class of our course about the complete introduction to data science. So in today's class, we are going to talk about another algorithm that is really present inside of machine learning. And in this case, it will be logistic regression. So basically what we'll do today is we are going to work with another tool that is pretty important in machine learning that is called sklearn. Basically, sklearn is a machine learning library that will offer you various machine learning tools that you guys will be able to work with. So basically you will have access to all the algorithms, so logistical regression will be in it. You will have all the other algorithms that we talked about a little bit before in the class in a more theoretical way. All right, so basically the first thing that you guys will need to do is import the sklearn inside of your PyCharm text editor. So as always, simply go on your file right here, inside of your settings, project interpreter, click on the little plus button right here and simply write down sklearn. So when it's done, it should be this one right here. Simply click on install package and you guys should be able to have it. So as you can see, I'm having it right here. All right, so when it's all done, the next thing that we want to do is really jump into it. So jump into what we are going to create. So for the purpose of this class, what I decided to do to make it the most simple possible is to work with confusion matrix. So basically confusion matrices will give us, will explain us more easily our model and will allow us to know how our model is good in terms of predicting something. So basically what I decided to do is create a really basic example. So when I'm talking about example, what I mean here is let's say someone is looking for a job and this person it's a management position job, and this person needs to have experience in 3 fields. And basically, depending on the experience of the person in those 3 fields, this person will get a job or not get a job. And basically, we want to predict the fact that this person will, the accuracy of our system to predict if this person will get a job or not get a certain job, depending of its experience. So what I'm planning to do is with pandas create arrays where we are going to store everything, basically databases where we are going to create our own data set. So basically you will create your own database in this case. So what I suggest you guys to do is really use 25 elements inside of your database, and from this moment we will create our little program that will be able to predict if yes or no our model works fine or no, if it's accurate or no. So let's start. So basically the first thing that we need to do is pretty simple. We need to import everything that we will need for our for our class. So pretty simple. We are going to start with Seaborn, so we'll import Seaborn as SN. We'll also need matplotlib to be able to work with graphs. Plotlib.pyplot. Then what we'll need also would be pandas. We also would need some things from sklearn. So basically we will import them. So from sklearn.model, we want to import train test split. We also need logistic regression, since we are going to perform a logistic regression and show the results inside of a confusion matrix. So we are going to write it down right here. Here we go. And finally, the last thing that we will need, just correct it to be sure it's written correctly. Logistical regression. Here we go. And finally, we'll need metrics. So from sklearn, we would need to import metrics. All right, so right now we have all the elements that we need to be able to create our, well, basically our database. So for the database, it's pretty simple. What I did is, as I said, I created 25 elements. So the elements are already pre-created. So I'll just show them to you. So basically, it's pretty simple. I have my candidate right here, or the person. Let's call it the person. I prefer person. So basically, the person will have experience in finances, management, logistics, and finally, do the person get work, yes or no? So it's pretty simple. Once again, we have our person number one, and what we have here is how many years of experience this person has. So as I said, it could be 1 year, 2 years, 5 years, anything that you want. All right, so the first thing that you guys would need to do is create a simple database that looks something like this. And then what we'll do is we will simply put all this together and create a data frame where we are going to store everything. So when you guys are done, what we'll do, we will create a data frame that we will call data. And inside of this data, we are going to, with the help of pandas, so basically we are going to refer to pandas, we're going to create a data frame that will store person. So basically all the elements inside of person, and basically in our columns, we want to have finance, management, and logistics. So here we go. So inside of our columns, we want to have finance, management, and here, and finally logistics. And what we need also would be our get work. Here we go. Get work. All right. So right now we have everything that we need. The next thing what we want to do is verify if everything works fine. So we'll simply print our little data. So we'll print our variable data, just to be sure that everything works fine. All right, so as you can see, it's generating perfectly right here. Everything works fine. So let me just explain the data to you. So as I said, here we have our years of experience for the 3 first of them. So finance, management, and logistics in years of experience. The next thing that we want to have would be zeros or ones. So basically 1 means the person gets the job, 0 means the person doesn't get the job. So it's pretty simple to understand. All right. So right now that we have everything that works here, it's time to get to the next step, which would be creating our logistic regression in Python. So for our logistic regression, what we'll need is pretty simple. We'll need 2 variables that will be x and y. So basically they will be inside of our graph. So for our variable x, what we'll have is pretty simple. We'll have the elements finance, management, and logistic as well. So what we'll do right now, we'll simply make a reference to person. So we'll write down our variable person. And from person, we want to use, in this case, finance. Management. And finally, logistics. The second variable that we'll have will be the variable y, and this, let's put it in small letters. And this variable will store get work. So basically, once again, from person, we want to have get work. So if the person gets work or no. All right, so right now we have our model. The next thing would be creating our test, well, using the test split function to be able to test everything. So basically we are going to decide what percentage of the database will be used for testing and which one will be used for training. So pretty simple. How exactly do we write this? We simply write down X, so we'll put it right here, X train, X test, then Y train, and Y test. All this would be equal to train, test, split. So basically what I'm writing right now is how much I want for my data, how much I want of my data set to be used to test, and what percentage of my data set I want to be used for training purpose. So basically I'll finish writing and I'll explain everything. We'll have X, Y. So we'll have our test size. So in our case, we want a test size of, let's say, 30%. So this means that, we'll put 0.3. So this means that we want we want to use 30% of our data set for testing purposes, and the other 70% will be used for, training purpose. And the second one will be random state, and this one will be equal to 0. All right, so when it's done, so right now with this line of code right here, we are able to say what will be the test split, so how much would be used for testing purpose and how much would be used for training purpose. So we have everything that we need right there. All right, so when it's all done, the next thing is pretty simple, is writing our logistical regression model. So it's pretty simple. We'll do it down there. So it's gonna be logistic regression. So in our case, let's call it logistic reg, which would be pretty simple. And logistic reg would be equal to logistic regression, since we are applying logistic regression to it. So this would be our variable in which we are going to store the function logistic regression. All right, then the next thing is pretty simple. Let's call it LR. It's gonna be smaller and more easier to work with. So we'll have LR, which would be equal to logistic regression. We will not have to write down each time logistical regression. So we'll have LR dot fit, since we're fitting right now our training of X and Y. So X train as well as Y train. Here we go. X in capital letters. All right, so right now we have everything that we need. Really important not making mistakes. All right, next thing that we need is we want to predict our regression right here. So Y. In this case, we'll call it prediction. Will be equal to, in our case, logistic it's LR. So it'll be equal to LR dot, and what we want to do, we want to predict the test of X. So in this case, predict X dot test. Here we go. So basically right now we have everything that we need to be able to run our model. Then the next thing that we want to do, since we want to put everything inside of a confusion matrix, we will create our confusion matrix right now. So basically our confusion matrix will be created with the use of once again pandas. So pretty simple. How exactly do we create our confusion matrix? We need at first to create our variable, which would be called conf mat. So let's call it conf mat. Let's use small letters as well. All right, so in this case, we'll have confusion matrix. and the confusion matrix will be equal to, in this case, so we'll have our Y test as well as our Y prediction. Then we'll have our row names. So how we will call our row names inside of our confusion matrix. So in this part of the code, we're creating our confusion matrix. And as I said, here we go. So right here, as I said, what we'll do is we will give row names to our rows. So pretty simple. Let's do it right here. So row names, we'll have row names. So for the first row, we will have right there, let's call it, I don't know how we can call it. We can call it, so it's right now. So basically true results, so true. And for columns, since it's everything that will be predicted, let's call it, I don't know. Let's call it provisions, since this is what will be predicted. So we'll call it prevision. All right, so we have everything that we need. The next thing that we need to do is we are going to use Seaborn to create our confusion matrix right now. So pretty simple, sn dot heat map. So basically in this case, we're going to use a heat map to be able to see everything, well, to be able to see it more clearly when our confusion matrix will be generated. And in this case, we are going to apply our heat map to our confusion matrix. So you'll see it's going to be something that is pretty cool. In this case, we call it conf mat. All right, so we have everything that we need, and annotation is going to be true. All right, so we have everything that we need. And finally, the last step will simply be printing everything. So basically, we want to print absolutely everything. So print accuracy. So here we want to print our accuracy score. And here we'll have our Y test. So we'll have our Y test and what we have predicted for our Y as well. So here for our accuracy score, we'll have our Y test as well as what we have predicted to our Y. So training and predicted. So the variables that are right here. Here we go. It's gonna be Y test. Also here we'll have our Y train as well as our Y predicted. Here we go. So right now we have everything that we need. So very important, a really important part of when we have done doing all this would be correcting our code because usually when we write down a huge code like this, it's really important to correct absolutely everything that we have just done. All right, so the last step will simply be writing down plt dot show to be able to see everything that we have. So what we'll do right now is we are going to run everything to see if it works perfectly, and if not, we're simply going to correct mistakes inside of our code. So if we run everything, okay, we can see that there is a mistake. So 0 size array to reduction operation if min which has not identified. So what we'll do right now, we'll simply look at our code and try to find the mistakes that are inside of it. What could be the mistakes that usually happen? So usually the mistakes that happen in those types of code will be basic mistakes. So I already see some of them. So basically I can see it right here. So we have y test that should be here. Well, we should have y prediction that is right here. So we have this mistake right there. Okay, so basically the mistake that we have is pretty simple. So we have here y test, y train, and here we should have y prediction instead of y train. So here we'll write down y prediction. And finally, the other place where we should have y prediction should be here. So this is exactly what we will do. So we'll keep our y test. And we are going to write down our y prediction. All right, so normally right now we should have everything that we need. And if you guys you have an error inside of your code or whatever, you can simply copy my code right here. It should work properly. All right, so at the end, this is the result that you guys should receive, and this is a perfect result of usually what you guys should have. So here you'll have your accuracy. So basically the accuracy of our model is 75%. So we are able to predict at 75% how many people will be, well, how many people will get the job and how many people won't get the job. How exactly does it predict 75? So it's pretty simple. The calculation of this is the true. So basically what are what is the true? So basically the true positive, we can say it this way, and versus the provisions. So basically here we'll have our provision. So basically provision of a yes, provision of a no. So here we'll have our true yes, a true no right here. And basically how we make this calculation, it's pretty simple. So we are going to make an addition of what are all the provisions that we have made that happened. So basically it's going to be this one right here and this one right here versus all the provisions that we made that basically didn't happen. So basically we made 3 mistakes right here and 0 mistakes right there. So it's simply going to be 8 plus 1 and all this divided by the number of provisions, which would give us 75%, which makes pretty much a lot of sense. So as you can see, this is how we are performing this type of regression. So as you can see, it's not, well, yes, it could be complicated, but at the end of the day, your goal is really to have this, to see how accurate is your model. So in our case, it's simply going to be 9 divided by 12, since we are going to make 8 plus 1 divided by the, well, all this. So basically 8 plus 3 plus 1. That should give us 75%, and 75% of accuracy is pretty good for this type of model. So as you can see, this would be the first model that we will create right now. So the first machine learning model. So this is the code around it. So basically, I tried to make it as simple as possible, but it's pretty normal that you guys have mistakes in a code that is big like this. But once again, if you guys still have mistakes, pretty simple, just screenshot my code and you can simply retype it and you should have everything that you need. So that's it for this class, guys, and see you all in our next class.